All right. Hello guys. I was just wanting to look at some Euclidean geometry. It's been a while since we've done any grade 11 Euclidean geometry. I just need to check here in the live session what grades do we have. But I just wanna probably spend a bit of time and do some Euclidean, right? But before we jump into it, I want to recap, review, recheck. Okay, just wanna see if we can see this diagram-ish. And see this diagram well, huh? Can we not? Can we not? Can we all see this question that is there in front of us there? Or we can't clearly. So anyways, in this question we are told, it says in the diagram below, right, triangle ACD is drawn with points. We can't see the statement at the top. Is that for everyone? Can't see the statement. Is that everyone can't see the statement? Okay, it's proving to be a bit of a challenge more than I thought. Thought it wouldn't be, but it seems like it is. Still bad as well. Amo, still bad. But in the we're told in the diagram below, triangle ACD is drawn with points. So let's look triangle ACD. So it's triangle A is there, C is there, and then D. So it's this triangle ACD. So it says in the diagram below, triangle ACD is drawn with points A and D on the circumference of the circle. Okay, so point A and point D are on the circumference. Remember, the circumference is the outer edges of the circle. Hey, Avu, you need to calm down. Avu is already jumping into the question. And then it says CD cuts the circle at B. So CD, here it is, where's CD? CD cuts the circle at B. So this is where it cuts the circle at B. P, which is this point here, is on what? Is on AD. That's P. With CP, CP. Here's CP, guys. CP, the bisector of what? Of angle ACD. So CP is the bisector of angle ACD, meaning this entire angle. All right, I'm gonna go into like the meaning and all of that stuff because that's what's important here. CP cuts the chord, so CP cuts the chord what? AB at what? At T, so that's there. And then we are told that AT, so AT is equal to AP. All right, now we see there's the little symbols there that mean that those sides are equal, AT and AP. And then we are told angle ATP, which is this angle here, is 65 degrees. You can see that the 65 is there. And then PCD, PC, right? PCD. So that angle there is 65 degrees. Okay. Yeah. So now we are being asked to do what? To determine the size of each of the following. And the first one is angle P2. All right. Now, guys, I just want to say that before you even jump into answering the question, what's important here is being able to read the statement. Like, we need to be people that can read the statement first and foremost. You read the statement, right, in the diagram below. Okay, so obviously this is a diagram. Triangle ACD. Now, the minute they say to you triangle ACD, hopefully and surely for most of you, there's a lot of things that start jogging in your head when they talk about triangle ACD. The thing is, there's things that you learned. Okay, there's things that you learned in grade 8, 9, 10 on geometry when it comes to triangles. Those things are still relevant and so important for you to know right now in your grade 11 year. Okay, so I'm sure some of the things that are coming into your mind, and I'm hoping, guys, that some of the things that are coming into your mind the minute they say triangle, you're thinking of sum of angles in a triangle. You're thinking of exterior angle of a triangle equal to the interior opposite angle, the sum of the interior opposite angle, sorry. You're thinking about angles opposite equal sides. You are thinking about equilateral triangle, the fact that if there was an equilateral triangle, then obviously the individual angles would be equal to 60 degrees. And all these things should come to mind. You should be thinking about Pythagoras, okay? But of course, like I'm just saying, generally speaking, when they mention the word triangle, so when they say triangle ACD, that's a key statement which should actually bring back a lot of things that you've learned, many theorems around triangles. Because if you've forgotten those theorems about triangles, then it will make this diagram a very daunting diagram. Okay, so I'm just saying, when you read the statement, there are keywords here. So triangle ACD is drawn with points A, there's A, D on the circumference of the circle, and of course A and D are on the circumference of the circle. Okay, then CD, where is CD? So CD, what does it do? It cuts the circle at B. Okay, right. Then P, there's P, is a point on what? On AD. Very important. With what? With CP, the bisector of angle ACD. You see, the thing is, this word bisector, that's another important word there. The word bisector. What does the word bisector imply? Because you can either have a bisector that will basically divide an angle into two, or it will divide a side into two. All right, so a bisector can either bisect an angle, meaning when it bisects that particular angle, then obviously the two angles will be equal. But if the bisector bisects a side, then it will cut the side into 2 equal halves. So you either have an angle bisector or you have a side bisector. So in this case, CP, this line segment CP, what does it do? It bisects the entire angle ACD. So you can see that it's divided into C1 and then obviously CPCD, which is 25 degrees. So those two angles, it should imply something to you. And then we are told CP cuts the chord. With CP, that's CP, it cuts which chord? This chord. AD is a chord. Hopefully we know what a chord is. Okay, very important what a chord is. All right. CP cuts the chord AB at what? At T, which is there. Then we are told AT is equal to AP. AT is equal to AP, which is 65 degrees. And then we are told that angle PCD, angle PCD, so that angle is 25 degrees. Please take note as well that the notation here, PCD, when the letter is in the middle with the little cap on top, then we are referring to that angle. So we just use this by convention, PCD, but the middle letter denotes the angle. So it's 25 degrees, and you can see it's already inscripted in our diagram. So after reading the statement, identifying the keywords bringing back a lot of theorems that you have learned, and you recalling those theorems, then you should be able to transfer all the information that you have on this diagram, on the statement, onto the diagram. Okay? Yeah. And then you cook, ready, set, cook. And you cook away. All right. So those are the things that you are given in the diagram. Now, we cannot assume, guys. Okay. We do not assume things. Okay. Kurt is saying, does AB do what? Bisect CD? No, we are not told that. All right. We are not told that. So we cannot assume it. All right. We are not told that it does, so we cannot assume it because it's not in the statement. We don't ever assume something that we are not told. That's like, for instance, you cannot say that P is the center. I'm sure a lot of people are like looking at P and they're like thinking, it must be the center. Guys, we are not told that in the statement. So therefore we cannot assume it, because if we do, then we are bound to make certain errors which are not true. All right, make certain statements which are not true, and therefore it's very, very dangerous to us. So like I said, please guys, read the statement. After reading the statement, pick up the key points. There's keywords, triangle ACD. Like I said, there's theorems embedded in that. The circumference of the circle, obviously guys, circumference of the circle, very key word there. Bisector, must know what the word bisector means, right? The minute they tell you AT is equal to AP, where the triangle, that should imply something to you, all right? So these are important things here that we can get from the information statement there at the top. Then, like I said, we transfer the information into the what? Into the diagram that is relevant. And then we move and we come here. The first question that they are saying here is determine the size of each of the following. 8.1.1, they want us to find the size, the angle what? P2. Okay, so I see a lot of people in the comment section, and I want to comment on those things. So Luniko the 66 says P2 is a isosceles triangle. Guys, please don't say things that you don't mean. Okay, P2, angle P2 is not an isosceles triangle. Please guys, okay, rather I would love if you would say something else. Don't say P2. This is an angle, remember, this is angle P2. You can't say P2 is an isosceles triangle. That's an incorrect statement. Okay, Lifa says P2 is equal to 65 degrees, angles opposite equal sides. That's Edge RSA as well. Sorry, that's Edge RSA saying that, as well as LIFA 012. LIFA 012 even goes on to actually write down the reason in short form, you know, angles opposite equal sides in short form. This says ATP. Thank you so much. So triangle ATP is an isosceles triangle. That's very true. But the thing is, here as South African students, we know that formally, whenever we say angle P2 is equal to 65 degrees, all right, we do not use an inappropriate reason, like, for instance, saying base angles of an isosceles triangle. We don't use that reason. Rather, you know, because of our document, the acceptable reason document, we say angles opposite equal sides. And I just wanna you know, let's pin. I wanna pin Lifa's comment here. This one. I'm sure you guys can see the pinned comment, right? P is equal to 65, right? I'm sure Lifa wanted to say 65 with the degrees, of course, no doubt, because, I mean, they know very well it's an angle. But then we say angles opposite equal sides, right? Please, guys, with that short form, as presented in that acceptable reason document that we have, angle P2 is 65 degrees. And look, guys, it's 2 marks. So that means our statement P2 is equal to 65 degrees, and then our reason, angles opposite equal sides. Please, angles opposite equal sides, that is the appropriate manner in which we go about answering what angle P2 is. And what we then do is that after you've written that down in your paper, that P2 is equal to 65 degrees, please then go ahead and update your diagram with the new information that P2 is now 65 degrees. So that when you look at your diagram again, you can see what you have gotten so far, because you've just answered that question. All right. So let me be very aggressive and let's invite some people up here. Hey, it's always better. Hey, I don't want this smaller nyana one. Let's change this one, not this one. Let's switch to this one. This one is too small. Hey, here's this the main guy.
Yeah. You can see that P2. I'm good. How are you?
No, I'm doing very well, sir. I'm doing very well. I can see you. It's like you are feeling very hot inside. You just want to jump in and attack, eh? Like you are in a geometry like one.
I enjoy doing the ECC. That's why.
Yeah. Tell me, my brother, just before you go on any further, I just want, for introductory sake, you know, and then I'll allow you to unleash your raw on the problem, so that you annihilate it as you want it. But so yeah, just to check here, you are we in essay doing grade 11 or 12 or not?
Yeah, I'm in essay. I'm doing grade 11. So
okay.
I'm doing grade 11. Yeah.
So all right. No, I just wanted
but
to.
I feel like I'm doing grade 12.
Sorry, you.
Yeah. So I feel like I'm doing grade 12. So yeah.
What do you mean you feel like you're doing grade 12? Right? You must explain that. What do you mean?
I am playing, sir.
Hey, you are a lion. I can see it. You are a lion, you. No, it's no problem. So you can continue for us. That's it. So I can see you are very hungry. You want to just annihilate this question in its entirety. So you can go ahead. Let me give you a free rein here. Is my man Deseto still here? Hey, what is this now? What's happening? Have we lost the set or there?
Okay. When I'm solving Euclidean geometry, first thing, I'm always
Okay, I don't know what's happening here because I seem to be losing. Okay, guys, I can't hear the set, so I don't know if I'm the only one struggling to hear him.
5 angles opposite equal sides. So we can see that P2 and P1, they come from the same line with CA. We can't call it a chord because of its. Okay, let me see. AC. To find D, angle D, so you can find D1. You can find B1. P2 is equals to B1.
P2 is, did you say?
P2 equals to B1. They come from P2 is equals to B1.
Reason?
Angles in the same sec.
Angles in the same seg. Now let's hang on there a little bit, I want to check something. You said angle P2 is equal to B1 angles in the same seg. My question is, BPAC, are they on the circumference of a circle? Were you able to prove maybe that they are this is a cyclic chord and therefore these are truly angles in the same segment?
Let me see. No, I wanted to say T. This network. Yeah, they are not inside the circle. So for us to find the angle D, we can find T3. T3 is equals to 65. Vertical opposite equal sides. Equal the angle there.
So let's hang on there. Let's hang on. Let's take it one step at a time. So you just said now, right? We are leaving behind that idea that we are going to say P2 is equal to B1 because we can see that P, A, C, B are not on the circumference of the circle, right? Okay. So you just said now you are moving from that and you are saying T3 is equal to
65.
Okay. All right. And the reason?
A vert opposite equal angle.
Okay, so vertically opposite angles. Okay, are equal. All right. Then?
So we can find B. Sir, can I ask, do we have a tangent here?
So from the statement that we have there, we were not told about a specific tangent.
So we can use Chord theorem, ne?
So in the statement, there's nothing that says something is a tangent.
Okay. Yeah, so we can find B1, triangle CTP.
We can find B1, triangle.
Yeah, since we have T3.
That's true.
CTP.
Okay.
Yeah, after finding B1, we can find B2. That's a long way. B2, which angles on a straight line. Yeah, I think so.
Okay, so after finding, so you found T3, you said 65, and then you said B1 as well. So what is B1?
180 minus 65. It's 100. Yeah?
180 minus?
It's 80. It's 90. Yeah, it's 90 B1.
So B1 is 90.
Yeah.
Okay.
Yeah, B1 is 90.
Very true. B1 is
Yeah,
90.
that means that B2 is also 90.
B1 is
And
B2
B2
is
is
also
also
90
90
degrees.
angles on this. Yeah,
Okay.
so that we
Angles
can
on a
find
straight
angle
line.
D now.
Okay, I'm listening.
Yeah, since we have B2, A2 it's also simple to find it because there we in triangle ATP we have T we have angle ATP and angle P2 which are equal.
Yeah.
Yeah, so we can find angle A2 and B2
Which
we
is?
also have so that we can find.
What's angle A2?
Okay, let me see. It's like 50, yeah. It's 130. Okay, it's like 50. A2 is 50.
A2 is 50. What's our reason?
It's a sum of angles in a triangle.
Okay, beautiful. And okay, and then we're coming very close.
Yeah, A2 is 50, B2 is 90. So our angle D is equals to, let me see. It's like 40, yeah, 40.
Okay. All right.
Yeah,
Beautiful. You did well. So let's just recap. Let's recap from the beginning, from the top. Though long it is, it helped us to get
yeah.
to the answer, and that's fine. So you said initially from the get-go, 8.1.1, you said P2 is equal to 65
Angle,
degrees.
yeah.
What was the reason?
Angles opposite equal sides.
All right. So that helped answer our first question, 8.1.1. You know, that P2 is 65 degrees. And the reason, as he said, angles opposite equal sides.
Equal
Then we went
sides.
on to 8.1.2. And then you said for 8.1.2, where did you start?
Yo, and it's 2 marks. Yo.
I know. But let's do it. Let's do the long way, okay? We'll come back and just check if there's maybe a quicker way. Because yes, it is 2 marks. So obviously, it must mean that there is a shorter way. So it's fine. Let's do the long way first, and then we'll come back and check if there's a quicker way.
Okay, yeah. So we can find T3.
Yes.
T3 is equal to 65. Vertical opposite equal angles.
Okay, vert op angles equal. Yes. Then,
Yeah. We can find B1.
all right, and you can find B1 using
Yeah, sum of
triangle
triangle
CTA,
CTP.
CTB. Okay. So you
Yeah,
said
so
B1 is
is
equal
equals to
to?
180 minus 65 plus 25.
Okay. I get that logic. So you got an answer of, and the reason, what's the reason?
Sum of angles in a triangle.
Very important, that one. Eh? So B1, angle B1 gives us, you said 90. Eh? I think you
90,
said
yeah.
90. All right. Then after that,
Yeah, we can find B2 angles on the straight line.
okay, angles on a straight line, B2 is equal to 90 degrees, angles on a straight line. Okay, our reasons are very important, angles on straight line. Then,
Yeah, after finding B2, it's 90. Yeah, so A2 is equals to 180 minus 65 minus 65 volts.
okay, A2 is equal to 180 minus 30 degrees, and our reason there is sum of angles in a triangle, right?
And sum of angles in a triangle. Yes.
Yes. And you got what? What's 180 minus 30, you said?
Yeah, so I got 50. I got
Okay.
50.
Nice.
A2.
And then last but
A2 is
not least,
angle D is equals to 180 minus 90 plus 50.
okay, 180 minus 90 plus 50 in those brackets. Our reason is
Sum of angles in triangle.
okay. And then you get an answer of what for angle D?
Angle D, it's like 40. Yeah. 90 plus
Okay,
50 and 40. Yeah, it's
40.
40.
Thank you so much. Thank you so much.
Yeah.
Now, like I said, to say it, so it's okay that you were able to get to the answer eventually. I see the method obviously was long, but the beautiful thing is you were able to get to the answer, right? And in the process, there's a lot of other information that we've been able to gather for our diagram, which is not a train smash. You see,
Yes.
I understand the whole thing of mark allocation, but one of the things that's actually quite nice about what you've done is that now you've populated your diagram with a lot of new information, which will probably help you in subsequent questions, you see. So that's why I'm saying it's not a train smash, and you shouldn't feel terrible that you weren't able to find the quickest, shortest method, right? But But let's see what would have been the quickest way for us to be able to get to that answer. Just want to see if there's anybody maybe who can. I saw. I'm seeing a few people on here. Let's just check. Maybe my brother here from the first statement has a quicker way. Oratile,
Listen,
are you rattering your life, my leader?
am I?
Are you loving your life?
Yes, I do love my life. Yeah.
I'm happy you do. I'm happy you do. Well, what does the name mean, Oratile?
What I did, I like laughed.
Oh, loved.
Yes.
Oh, okay. Yeah, that's why I'm
What I
asking
did,
you. You
like
see, like, hopefully it's not like loved past tense, but it's you love present tense.
no, it's kind of past tense because it says ora did, like I loved.
Yo, you see, hence I was asking you, do you love your life currently? No, not in the past, but even currently.
Yes, currently I do love my life.
Ah, that's beautiful, my leader. That's beautiful. Now, do you perhaps have a quicker way to get to angle D after answering this question 8.1.1? Because remember, we were being asked initially to find angle P2, and we got it. It is 65 degrees. Now, I wanted to check, since it's 2 marks and probably the steps that we could take are much more quicker, do you perhaps have a quicker way to get to angle D?
Yes, there's a quicker way.
Sure, man. You give it to me. Let's check out the quicker way.
Let me introduce myself first now.
No problem. Please do.
Yeah. Okay, my name is Oradile. I'm from Pretoria. I'm doing grade 11.
Epic. Okay.
So the quickest way, actually, the problem, I don't have a calculator on me. I was watching videos, then I got interested because I love math.
You're watching videos. What videos were you watching?
No, I was just on TikTok relaxing. Then it popped up
Oh,
to
you were
my
relaxing. Hey.
yes, and like I enjoy math, so I just like I'm staying here.
Oh, okay, okay.
Okay,
Can I ask you just another question just before you jump into this? How did you do in term one already?
no, I did excellent distinction. Math is my
Distinction.
things. Yes, math is my things.
Maths is your things. Like specifically, can you be specific about the percentage you got?
The percentage I got,
Yeah.
it was level 7, something 4 behind. Is it 80 or 90? 4.
Yeah. Which one? 90, 80. 90, 80.
Let me check for you. The report is near me. $94.
Yo. You're doing the most. You're doing the most. So we're
Yeah,
expecting nothing less than that in this term. That's for sure, then, eh?
yeah. Especially I'm
Yeah.
doing geometry. I love it.
Yeah, that's power. I love it. I love it for you too, man. I love it for you too. We must keep that up. So we're expecting more than you've set your benchmark for the year. So that means for the year and moving forward, you are never going to achieve something less than 94 because when you adjust a 94 and above a character. So it's good. No one you're not competing against anyone but yourself. So you've set that benchmark. So you have to operate there, my leader. 94 and above. That's you for the rest of the year. You know.
Yeah. Actually, I
Yeah,
want
the
100%.
challenge is on. I get that's power, Baba. That's even more powerful. All right. So
Yeah.
I was just checking. All right, Deal, if there's any quicker way to get to that angle D there.
Yes. So since P2 is equals to 65 degrees, which the reason was angles opposite equal side,
Yes.
then we can get P1 angles on a straight line, which is
Oh,
180
angle.
minus 65 degrees,
Yes.
which the answer is 115 degrees.
115 degrees. Not forgetting our reason, of course.
Yes, it's angles on a straight line.
Awesome. Okay. Then
So angle D is equals to, can you remove the camera this side?
angle D. Sorry.
Is equals, is it C? Yeah, it's angle D is equals to angle C. Angle D is equals to 180 minus 25 degrees minus 115 degrees. Sum of angles in a triangle.
So we're looking at triangle PCD there.
Yes, PCD.
Oh, I see.
And we got our angle D, which it will
Beautiful.
be 180 minus 115 minus 25. So it's gonna be 40 degrees.
Yesterday. There it is, eh?
Yeah, shortcut.
Okay. That's one shortcut in the bag. I believe there's another one. There's another shortcut. Just sorry. Let me just. I can see there's a guy there who is hungry to come. But Oratile, thank you so much. That was straight to the point, my lead. I can see now the 2 marks. You see?
Yes.
Yeah, the 2 marks. You know. So I suppose there's many roads to our destination. Whether you decide to sort of like you said you're in Pretoria, hey?
Yes.
If you decide to move from Ferry Glen and you go to Mamelodi so that you can get to Menlyn Mall, that's your choice, right?
Yes.
Or you can move from Ferry Glen directly, you know, like take the shortest distance, displacement to the place, and there you are.
Yeah.
Yeah. No, that's fine. All right, Tile, thank you so much. I want to entertain this guy, DeMarco. I don't know if he has another short way to get to angle D.
Okay.
DeMarco,
Sure.
are you well, sir?
I'm fine, and you?
I am doing awesome. Hey, people are helping me out like insanely here on this live. Like I'm meeting top-notch students from across the country, and I'm just impressed, you know. So my leader, I wanted to. I don't know if you've been listening, but like we were looking at this question 8.1.2, and my first guest, he was able to get to angle D. Get me the angle D using a very long method, but what was beautiful is that we're able to get other angles and eventually get angle D. Okay. Now I just wanted to check with you. Do you perhaps know of a quicker method to get angle D since it's 2 marks?
Since it's 2 marks.
Yes.
Okay. I was gonna say, like, since we have equal size, the AP is equals to AT.
Yes.
And then I would say, like, angle P2 would be 65.
Angle P2 is 65. Yes, that was for our first question. So angle P2 is 65 degrees. And your reason would be?
Isosceles triangle, or you can say opposite. You can say equal. What can I say? I can say isosceles triangle. Yeah.
Now, Redbird, I don't know, DeMarco, about you, but you see, the thing is, we are fighting that reason very hard, the one about isosceles triangle. We are really trying to acclimatize ourselves to that one fundamental important reason that says angles opposite equal sides, you see?
Okay. So.
Yeah, so we are fighting that one, especially here in the South African context, for our students here. grade 11, grade 10, 11, 12. So angles opposite equal sides is the acceptable reason according to the acceptable reason document. So we want to acclimatize ourselves and stick to that reasoning, not isosceles triangle. Isosceles triangle is not going to, be too viable. Maybe in grade 8 and 9, they would have been a bit lenient, but 10, 11, 12, we can't exercise that sort of leniency. We have to make sure that we are saying angles opposite equal sides. Okay, so that's P2, all right?
Okay, che.
Then angle D, my leader, how would we, for 2 marks, get angle D?
Oh, okay. And then after that, I'll say P1 is equals to that angle, 180 minus that angle. And then I'll say angles on a straight line.
Sure.
And then I would find D using sum of angles in a triangle.
All right, beautiful. So that means you and Oratile, you are on the same page. You are on
Oh,
the
you
same
already
page.
found it?
No. What I'm saying is Oratile did also find it that way. I am looking for another quick way besides the way that you guys have utilized, But I love it because now you've repeated it for those who may have not grasped it when we did it the first time, or maybe who entered into the live, whilst we were midway. So thank you for reiterating it. I love it. I love it. Yeah. I'm just checking for another alternative. So I'm gonna keep on punching in, getting some guests in here. So just be patient with me. Molez.
Hi.
Are you well?
I'm well, and you?
No, I'm doing sweet. I hope you can make my night even sweeter.
Let's hope.
Okay. I'm looking for this angle D. I'm sure you've seen how other people have gone on and actually found angle D. And my good friend DeMarco here in Oratile were able to utilize the same sort of like logical process to be able to get to angle D. After getting angle P2 for angle 8.1.1 using angles opposite equal sides, they got this angle P1 using angles on a straight line, and then ultimately they use sum of angles in a triangle to get angle D, which is 40 degrees. I wanted to check if there's any other shorter way to get to angle D.
We can use the exterior angle of a triangle.
Beautiful. Talk through with me for the purpose of those who are listening.
So we can see that in the triangle DCP, we have angle
DCP, yes.
We are given angle DCP, which is 25 degrees.
Yes, definitely. There it is. DCP, this angle is 25 degrees.
And then we can see that P2 is an exterior angle of that triangle.
Beautiful, true. And it is a true exterior angle, hey, because it is in line with the side of the triangle. So that's beautiful, yes.
So that means that if we can add angle D and angle DCP together, it should give us P2.
Hey, Ban. Hi, I hear you. I hear you very well. That's beautiful. So that's just one line, hey? Angle D, you are saying basically, would be equal to angle P2 minus angle DCP. And the reason would be exterior angle of triangle.
Yes.
Aye, that's beauty. 40 degrees. That's 2 mark worthy. All right. You hit it. Thanks. Wow. All right. No, thank you. I appreciate that. You definitely came with a solution to many problems there. Okay. So for those who are joining in, guys, Molez, just I hope that is the name and I'm saying it correctly. Mo?
You're saying correctly.
Oh, okay. So just for those who are joining in, guys, we got angle P2 from the previous problem. We had been asked what P2 is. We got angle P2 is 65 degrees, angles opposite equal sides. So now all that Moles has just told us, in order to get angle D, which is here, you must look at this triangle PDC. There's this angle here, there's angle D here, and then there's angle P2. If you look at the relationship of angle P2, this angle here, this 25 degrees, and this angle D, this P2 is an exterior angle of a triangle. Which triangle? Triangle PDC. Why do we say it's an exterior angle? It's because it is definitely the angle that is basically formed by PD being produced to A. It's in the same line as the side PD. So therefore angle P2 is the true exterior angle, and it's equal to what? It's equal to the sum of the two interior opposite angles. That's grade what? Grade 8, guys. You learned that in grade 8. All right? You know it from grade 9 as well, grade 10. So by now you should be like flying in these things. So therefore that's why we say, when we want to say angle D, we just say angle D is equal to, we take this beautiful angle here, P2, we subtract 25 degrees, that should give us what? Angle D. So therefore that's 40 degrees. Reason, exterior angle of triangle. So thank you so much. Wow, that was well, yeah, you guys know your stuff, that's for sure. You know your stuff. So thank you so much. Thank you so much, guys. I think let's zoom in a little bit more now and just come here to 8.1.3. We want angle A1. Can any of you kind people tell me or lead me in getting angle A1? Anyone who would care to be so kind and generous?
Yeah, I think I would.
Sure, DiMarco. Okay.
So finding A1, you'll say A1 will be equals to D because of tan chord.
You're saying angle A1 is equal to?
Angle D.
Is equal to angle D. And what's the reason you said?
Tan chord theorem.
Okay. Now guys, I just want to, I am going to play what I would refer to as devil's advocate. All right. Now there's this thing in Euclidean geometry that I just want to relook at what we have in the statement, right? It says in the diagram below, triangle ACD is drawn with points A and D on the circumference of a circle. Okay, so there's A, of course, then A and what? And D, there's D on the circumference of the circle. Then they say CD, which is CD, cuts the circle at B. All right. Then they say P is a point on AD. P is a point on AD. With CP, the bisector of angle ACD. Okay. They say CP cuts the chord AB at T. So CP, where's CP? CP cuts the chord at T. There. And then they say AT is equal to AP. Okay. Then they're saying angle ATP is 65 degrees. A what? ATP is 65 degrees. Then they say PCD is equal to 25 degrees. Now, I just want to say, and I want to say this very strongly and boldly, and I just want to also interrogate you guys in your minds. Right? In the statement, there's nowhere where we are told that CA is a tangent. Okay. And the thing is, we can't even assume that it is. Right? Yeah, because there's something very dangerous in geometry. Assuming something, we cannot assume that something is unless we can prove it. Okay, this is like me saying to those who were here earlier on that, for instance, you can't say P is the center of the circle unless you can prove it. Okay, unless you can prove it. So for this particular instance, for instance, angle A1, all right, I hear what you're saying, DiMarco, but I want to say to you that what if I told you that, how do you know for sure that that is a tangent? Where do you know that from? Who told you?
No. One thing I know about a tangent is that it touches a circle at one point. Yeah.
Okay, I hear you. That's a very true statement. It touches the circle at a point. That's very true, right? But then can I then dare to say to you that I would have to be like thoroughly convinced, all right,
Okay.
that it is a tangent. Okay, we cannot assume it, and this is what I want to really say and communicate to those who are. If you're good at geometry, I'm very happy that you are. But one of the things that you cannot do when you are answering a question is to assume something that maybe has not been stated, unless, of course, you have first proven that it is a tangent. Then you can actually go ahead and utilize all the things that basically are a result when something is a tangent. Okay.
Oh, okay.
So I want us to kind of veer off from the whole tangency thing, because look at the next question there in 8.2. Is CA a tangent to the circle ABD? Give a reason. Right.
Okay, so can I ask?
Sure.
Since I arrived there, did someone say B2 is 90?
Did someone say B2 is 90? Yes. Yeah. There was someone that said B2 is 90, and that was the person that basically went the long route towards proving that angle D is 40 degrees. But all of you guys that used the short method to get to angle D being 40 degrees, none of you actually stated that angle B2 is 90 degrees. So we'd have to look at, so the thing is, there would be, depending on who's answering the question, all right, okay, there would be people who would be able to actually state that maybe, yeah, that's the case with the AC, but there's people that can't state it yet because they've not proven it.
Oh, okay.
Yeah, I hope that makes sense. So what do you want to say? Let's move from where you actually left off.
B2. Okay. So if B2 is 90, then it means that AD would be a diameter, and then if that's that, and then angle A, the whole angle A would be 90 because of the theorem which says a tangent and a radius. Do you know it?
Yes. I know that theorem. Tangent.
And then you have to get A2. You say 90 minus that A2. And then if it happens to get 40 at A1, then that AC is a tangent.
Okay. All right. But back here, sorry, so I hear what you're saying, but back here, my good friend, 8.1.3. So where do we start though? Because remember, like I said, we cannot assume that AC is a tangent.
Yeah, I can see.
Yeah. So no tangent for now. You see, I hear what you're saying, but I'm saying at the moment. So where we at right now, we don't know that it's a tangent, but we want A1, and we are hungry for A1. Yeah. So and remember also there was something else that was stated here, that what is it? The bisector, the fact that CP is the bisector of ACD, and we already know that this side is 25 and so forth. So
Oh, can I try?
Oh, okay, you can try. I had an idea.
Sure, Molez, you can go.
So C1 will be 25 degrees.
Yes, very true. What's the reason?
It's because CP bisects ACD, so the two angles will be equal.
Thank you. That's very true. Now I hope for all the viewers, people who are watching, because you see the thing is there's no major theorem in our grade 11 syllabus that speaks to bisector. But this is something that we need to know, that you can either be bisecting an angle or bisecting a side. So the word bisect means to cut into two, and to cut into two equal half, right? So that's very important. So the minute you are saying this line CP is bisecting ACD, the entire angle, then you are saying these two angles, they are what? They are equal. And it's because of that statement. Okay. Yeah. So thank you for that. So C1 is 25 degrees, you've
25.
said. Okay.
Then
Let
T3 would be 65 because of vertically opposite angles.
sure. Okay.
Then we can use the exterior angle of a triangle.
Hey, the exterior angle of a triangle seems to be famous. You guys see that?
Then we'll find A1 to be 40.
Yeah, definitely. Definitely. So here, so just for those who are joining in here, we just said that C1, this angle is 25 degrees. And this is based on the fact that they said CP is the bisector of what? Of angle ACD, which means this line segment, it cuts this angle C so that these two angles are equal. So we say C1 is 25 degrees. Then Moles further on went to say that angle T3 is 65 degrees, vertically opposite angles. And then Moles went on to say this exterior angle T3, if you look at triangle ACT, T3 is the exterior angle. Then these two angles, A1 and C1, if you add them together, they should give you T3, right? So therefore, that means A1 is equal to, so A1 is equal to what, my good friend?
40.
Phakathi inside, 40 degrees.
So can I ask?
Sure.
Will I get it wrong if I said that a turn chord in the exam?
Okay. So you a good question. You are asking me, would you get it wrong if you said, so state what you were gonna say?
Oh, I said D is equals to A1 turn chord theorem.
D is equal to A1 turn chord. Remember, it goes back to what I said earlier on. Okay.
Yeah.
Yeah. So initially you cannot, until we can verify that this is a tangent.
Meaning it's wrong.
So, yes, the thing is, because we cannot assume.
But I can see it's 2 marks. Hey.
No, it is 2 marks. It is 2 marks. But you see, the thing is, and I guess that's why today would probably be very beneficial for some people. Even if you've got a good hang on the geometry, but this part of not assuming, and even there's this I actually uploaded a video on my YouTube channel where I was actually explaining the steps that you can sort of like the strategy that you use that you utilize when you are approaching geometry questions, and the fact that reading the statement is important, picking up on those keywords is important, making sure that you then transfer information from the statement to the diagram, and then ultimately not making assumptions, never ever making assumptions. So the statement here is very important because it helps you to understand what is actually really truthfully implied in the diagram. So then after doing that, then we can actually go ahead and answer the questions accordingly with the information that is true that we've gotten. Okay, so assumptions, guys, let us be wary of making assumptions unless we can prove that something is the way it is. Now check this out. Didn't they say A1 is 40 degrees? You said A1 is 40, right?
Yeah, I said.
Yes.
Yeah, you proved that A1 is 40 degrees. So now the next question says, is CA a tangent to the circle ABD? Give a reason.
Many can solve 8.1.3. There's another quick solution.
Okay. Who's speaking to me here?
Oradini.
Okay, Oradil. Okay, sure, Oradil, please. If there's another way, let's check it out.
Molest used 3 statements. He found
Yes.
C1 and T3, then found A1.
Yes. Very true.
So I was looking at the marks. So the marks are 2 marks.
Okay.
Yeah,
Okay.
that's what I see.
Then I realized, we know C1 because of the bisector is 25 degrees.
Sure.
Then T, we don't know that number. That 65 degrees minus 25 degrees is equals to A1, exterior angle of a triangle. ACT. Two statement like
Yeah,
that.
simple like that.
All right. So that is the one that is basically they were thinking of for the 2 marks.
Yes.
Okay. All right. No, that's fine. Yeah. The reason why I'm giving people an opportunity, and I'm sure like because people are like probably like, but we've gotten the answer, why don't we just move on? The reason why I'm giving you guys a chance to actually look and relook at the problem is because, like I said, if you want to go to Menlyn Mall, if you're in Pretoria and you are coming all the way from Ferry Glen, you can go all the way if you want to good Mamelodi. Go and have some good time there, and then you can go to Menlyn Mall, or you can just take the shortest distance to get there. You see, yeah. So I want that exploration, and also for people that are watching, they need to realize that with geometry, you see, this is the one topic where there are multiple ways to be able to get to the answer. But of course, oftentimes, what do? We check out the mark allocation and we try and see, is there perhaps, a quick way of being able to get to that answer? So the more we obviously give ourselves a chance to, to stay with the problems and do them, and we know our stuff. It's very important, know our knowledge of geometry that we established in earlier grades, everything about triangles, everything else that we know about lines, everything with parallel lines and so forth, then we can see these things. Because it's not only just the circle geometry itself, what we are learning in grade 11, that is important, but also what you've established in earlier grades. So, and you can see, guys, for all of these, 8.1.2, 8.1.3, our way out was exterior angles of a triangle. But you see now, the thing is, if you don't know that and you can't see it in the diagram because you're not accustomed to it, then it can be problematic for you, So these guys here, Moles, DiMarco, or Attila, these guys, they're going to be showing maths, these ones. You guys are going to be showing maths flames. Too much. Okay. So yeah, thank you guys. That was beautiful. So that one is very quick. C1 is equal to 25 degrees. Bam. The fact that C is the bisector of ACD. 2, exterior angle of a triangle. 65 degrees is equal to C1 plus A1. I mean, you can say A1 is equal to 65 degrees minus that C1, exterior angle of a triangle, pagati inside the answer. And that's it. Done and dusted. So thank you. Thank you so much. Yo. You guys are powerhouses, for sure. Now, the last part is CA tangent to the circle ABD. Give a reason.
Yes.
I think as already said.
We can start by writing A1 is equals to 40 degrees. Reason
Yes.
Proved.
Proved. Yes.
Then D is equals to 40 degrees. Proved.
Proved.
Angle A is equals to angle D. Both equals to 40 degrees. Therefore, converse of a... But we're not proving, so we can just leave it like that. It's always 2 marks.
Yeah. So basically, yeah. And Kengo, the reason is very key there. That reason is very key. Is CA a tangent? We obviously state that it is. It's a very big yes, like those guys have said, because what have you then seen? These two angles, A1 and angle D, that is an angle that is formed by a chord and a line here. And then this line that subtends this angle that's in the alternate segment, it's equal to that angle. So therefore, ultimately, that means that indeed CA is a tangent. It's the converse of the tan-chord theorem, right? And I think there's another alternative reason you can use besides converse of tan-chord theorem. If you look at the document for excitable reasons, there's that converse of tan-chord theorem, and then there's another one as well that's there, that you can check out to proving tangents. So yeah, guys, You guys, you are winners. Siyabonga, siyabulela. What more can I say? So yeah, no, I appreciate that. Guys, what about that statement? Can you tell me very quickly? The angle at the center of a circle is twice the angle dash what subtended by dash what?
The center is- Angle at the circumference.
The angle of the circumference.
The angle at the center of a circle is twice the angle.
At the
At the
circumference.
circumference.
It's twice the angle at the circumference subtended by the chords.
It's twice the angle of the circumference subtended by same chord.
Okay, hey, very interesting. So I heard you both say same chord, right? The angle at the center of the circle is twice the angle. You said twice the angle.
At the yeah, we can say
At the circumference.
circumference.
The angle at the center of the circle is twice the angle at the circumference, right?
Circumference. Yes.
Subtended by what?
Yeah, I was saying chords, but the comment
By an
was
arc.
something. It have to be arc.
Okay, subtended by the same arc. Yes, definitely. That same arc. All right. Yeah. Look, I'm sure mostly from that arc you can draw a chord, but yeah, by the same arc, right? Yeah. No, that's fine. Maybe let's come here now in this diagram. I think it's calling for you people as well. Let's check this one out very quickly. Let me give you your last minute of fame and glory on this live, if you will. So in the diagram below, O is the center of the circle. K, L, M, and N are points on the circumference of the circle. KS is a tangent to the circle at K, and L is equal to 100 degrees. Okay, so the KS is the tangent to the circle at K. Sorry, KS is a tangent to the circle at K. Okay, and then angle L is equal to 100 degrees. Okay.
How about we solve every angle?
How about we solve every angle? Let's go for it. Okay, let's go for it. Let's solve for every angle. I like what you're saying, and then we'll look at the proof type question that they're asking at the end. Let's go ahead. Let's solve for every angle that we see here.
Yes,
Okay.
let me do the first one. I can see a cyclic quad.
Okay, you can see
Cyclic quad.
Please tell me the cyclic quad that you are seeing. Which one?
MNKL.
MNKL. MNKL. Right.
Yeah.
I hope we can see that. Why are you saying you can see a cyclic quad?
How should I put it? Like I see 4 chords.
Okay, you see 4 chords. Okay, that's fine. You see 4 chords, so that's NK, that's NM, ML, and LK. All right.
Yes. On a second. So we can find angle N.
You can find
Angle N.
or angle N. All right.
Yes,
I think
angles of a cyclic quad.
so. Hopefully, all of you guys as well know the fact that if there's 4 points on the circumference of the circle, then that also suggests that we say that they are concyclic, which would suggest that this is a cyclic quad. All right. So it's not assuming anything. It's actually looking at what the statement is saying. K, L, M, and N are points on the circumference of the circle. That is just another fancy way, or sort of like a hidden way of saying cyclic quad. Like it's in your face. All right. Okay, so thank you so much for that. Okay, let's give you a chance. You said you want to find what angle, what size? What angle?
Angle N is equals to 80.
Angle
Yes,
N is equal to 80. Why?
opposite angles of a cyclic quad are supplementary.
Opposite angles of
A cyclic quad are supplementary.
Okay, but when you write down the reason, if I may ask, what do you write down?
Opposite angles of a cyclic quad.
Okay, thank you. Okay, opposite angles of cyclic quad. Nice. All right, and that's basically what I wanted. I wanted to hear that. Okay, so angle N is 80 degrees, you said, right?
Yes, it's going to be 180 minus angle N. So
Okay.
I just worked straight to the answer.
That's beautiful. And it's fine to do that, to go straight to the answer. Some people might feel that they want to write down that 100 plus 80 degrees is equal to, you don't have to, n plus 100 is equal to 180 degrees opposite angle of cyclic quad, and then they solve. You can go straight to the statement with its reason. Statement with already the answer solved, and then the reason. That's 100% fine, for those people that may be wondering. That affords you all the marks. You're not going to lose marks because you did not show the working out. Okay, so that's perfectly fine. All right, so you've helped us out with angle N. Who else can help here?
I think I will do O.
Sure, my lead. Angle O. Which one? Which angle O?
Which angle? O. Like at the center.
Yeah. Okay, I see, but which one still?
Ish.
Let's say the one on top is O1 and the one on
Okay, I get it. Okay. But
That's exactly what
it's not labeled.
Yeah,
Yes,
let's just label it.
That's what I wanted to get to as well. Hey, like the whole thing.
I would say I would get angle. I would get angle MOK. Yeah.
Okay, MOK. But you see, the thing is, MOK, there's MOK, the one that's closer to 100 degrees. There's MOK, the one that's closer to N. Which one?
No. The one that's closer to 100.
Okay. And so that becomes important. I mean, that's important that we distinguish between those. But the thing is, you can't put, and I'm saying this for those who are listening, we can't go to the diagram and write here 1 and then write here 2. We don't do that, right? Yeah, because it's very important that we utilize, our arms to be able to identify the angle we are talking about. So it's MOK, all right? And the thing is, there's a certain nature that this angle possesses opposed to the nature of this angle. This angle here tends to be a reflex angle. Okay. This one. Yeah. So if you're talking about MON, the reflex, and you can say that. You can say angle MON and then in brackets write reflex angle. So I know which MON you are talking about. You see?
Okay.
Yes, and that's very important because you need to distinguish this MON to this MON, angle MON. Okay. Cheers, Rory Sang. Good seeing you, buddy. Thank you for being here in the live, Mr. Tutor. There's some good people in the live comment section there. I've been seeing these guys. Some good people that tutor maths in the blog. So yeah, I hope that distinction. But we don't write this thing 1 and 2. Please, let's avoid that. Yeah?
So what should I call it? The one at the bottom.
You can just say angle MON. And then this one at the top will be MON. You'll say reflex. You see?
Okay, I would find it, the one at the bottom. I will say that.
Okay, no problem.
Yeah,
Let's go.
It's equals to 160 degrees.
Reason.
Reason being angle at the center doubles the angle at the circumference. Yeah.
Beautiful. That's beautiful. So angle at the center is equal to 2 times the angle at the circumference. So basically, because this was 80, which is what we had gotten earlier on, you times that by 2, you should get the angle at the center, which is 100% correct. Okay. We're moving on very nicely. Let's move on to the next one.
Okay, I can find M2.
Sure.
M2 will be equal to K2.
M2 is equal to K2. Right?
Angles opposite equal sides.
Okay, angles opposite equal sides.
Since OM and OK are radi.
Okay, nice. I love that. Okay, all right.
So M2 will be 10 degrees and K2 will be 10 degrees.
Okay, that's very true. 100% correct. 100.
Then K4 will be equal to M3 plus M2.
K4. All right, I see you are heading right straight to. So you're saying K4 will be equal to
M3 plus M2.
M3 plus M2. What is it?
Because of 10 chord theorem.
Oh, I see. Mr. Tangent here, the chord here, the triangle. 1, 2, 3 on the circumference of the circle. So this here, the angle formed by the tangent and the chord is equal to the angle that is subtended by the same chord. This chord subtends which angle? Angle M3 and M2 together. Oh, nice. Okay.
Yes, so K4 will be 80 degrees.
Ooh, power.
So then, since K4 is 80 degrees, K3 will be 10 degrees.
This guy is killing it. Okay, so since this is 80 degrees, you are saying K3 will be
10 degrees.
Reason.
10 perpendicular to radius.
Oh, Aisha. I see, eh? Okay, I see. No, that's power, Bob. That's power.
And K1 will be 80.
K1 will be 80. Reason.
10 perpendicular radius again.
This man is just chowing everything. He's chowing everything. I actually wanted no wait. You said K1 is 80 degrees. Are you sure about that?
No, it's not. I'm now realizing it now. It's not.
Okay. Yeah, because you see KL here. You see KL is not a tangent. Yeah. KL is not a tangent. So even though this is a radius, this is not a tangent. This is a tangent, so that warrants the 90 degrees, and then obviously 10 plus 8 being 90. But this side, hey, very careful, guys. You see, this here, KL, is a chord, all right? So now I want to venture and ask then, we got K4, we have K3, we have K2, we don't have K1. Can we find K1?
Yeah. Then you're left with K1 and M1.
Yeah, no, true. We are left with both. Like they are begging to be found, if it's feasible for us to actually find them. Aiden is saying use sum of angles in a triangle. Is it possible for us to use sum of angles in a triangle in this situation?
No, because of your two angles unknown.
Yeah, we have two angles unknown. So M1 and L and K1 we do not know. Sum of angles in a straight line. The thing is, KS is not a straight line. KSL is not a straight line.
I think I got it. I don't know if I got it. How to get M1?
How to get
M1?
Okay.
Since MLKN is a cyclic quad.
Okay, MLKN definitely is a cyclic quad, yes.
So let me see again. I'm not think it's gonna work.
Yeah, because
I was thinking of an exterior angle.
Exterior angle?
But it's not gonna work.
Yeah, because KS is not a straight line.
Yes.
Yeah, it's not.
Not at all.
And this one is
I'm laughing at some of the comments in the comment section. Sharon Mataji said, please explain again M2. Can you guys backtrack just a little bit and just go back and explain M2, just so that we can have our viewers on the same page? How did we get M2, the angle M2? Do you still remember?
Yes.
Yeah.
We knew that OM is equals to OK due to radius.
So we knew that M2 is equal to?
No, yes, M2 is equals to K2. Angles
Alright.
on both equal sides.
Yes.
Then we have that MOK, which it was 160.
We got this as 160 degrees, that's true.
Yes, so M2 plus K2, they're equal. So we'll just substitute one with another angle. Then we will get the common factor is going to be like, oh no, not common factor,
So,
we're going to add
so
them.
can I ask?
Yes. Someone said, "Can I ask?" As
And it's not, I think it's
No,
demarc.
I thought I saw something, but hey,
yeah. So in the actual questions that you have, guys, because remember, you are the ones that said you insisted you wanted to find all the angles in the diagram, which I had no problem with. But we were able to find angle N for 2 marks. I think that was definitely 2 mark worthy, because as per the diagram, to find angle N, we said the opposite angles of a cyclic quad. So we got angle N as 80 degrees, because the opposite angles of a cyclic quad, they are supplementary, as we would know. So angle N is 80 degrees, opposite angle of cyclic quad. Then after getting angle N, we were asked to find the size of angle K2, which you guys were also able to find, because initially you found angle O after finding angle N, all right? And then after finding angle O, you guys then utilized, the fact that angle M2 and angle K2, they are also equal because of the fact that MO and OK are radii, and the fact that it's angles opposite equal sides because of that. So therefore, then ultimately that means that if you have this 160 degrees, you add that and that together, you can actually sum it up to 180 degrees, and then you can find angle K2, which is 10 degrees. So you guys said angle K2 is 10 degrees, and that's what they wanted you to find as well for 3 marks. Okay. All right. And then the last question, all right, because I'm sure M1 and K1, you guys are going to have a field time actually trying to figure those ones out. But the last question that was asked here is prove giving reasons that MN is parallel to KS. Now let's go and check. Where's MN? Here is MN. They want you to prove that MN is parallel to KS. Now, before we jump into answering the question, can I just ask, what are the things that we look for when we want to prove parallel lines? Maybe you guys can help me out.
Fun talks.
angles.
Co-interior angles and
Alternate.
corresponding.
Okay, someone said something. It's almost as if like you said, what did you say on talks?
Fun talks.
Alternate angles.
Talks.
Tell
What
us
is
everything.
fun talks?
Fun talks.
What is fun talks now, guys? Hey, you guys are coming up with things.
Alternate angles, corresponding angles, every angles of parallel lines, they are fun talks. Because everything like they fall under fun talks.
Everything falls under fun talks. Okay, so the 3 fundamental things that we are always checking out here is we want to see, can we find corresponding angles that are equal?
Nah,
No.
alternate.
Can
Yes,
we find
we can
alternate
find
angles
if
that are,
if
can we-
if they say if we prove that MN is parallel to KS, so if angle N is equal to K4, then they are parallel.
very
In
true, eh?
2 ways.
You asked
Okay, so
about
that's one way we could prove that. Okay, so basically you guys are saying that there is possibly alternate angles that are equal that we can identify between these 2 lines, right?
Yes,
Yes.
and they
Yes.
co-interior also.
And have
Co-interior as well. Where
Yes.
guys? Where's co-interior? Possibly.
M3 plus M2.
M2.
It must
Oh,
M3 plus M2 plus K2 plus K3 plus K4. There must be 180.
I see. So this is the U shape.
Yes.
Yes.
The U shape. The U shape. So the Z for alternate angles. So if we can prove that angle N and angle K4 are equal, we are done. We are good. Then we can say
Yeah.
MN and KS are parallel.
Yes.
Okay. Or you guys are saying alternatively, if we can prove that angle M3 and angle M2 together with angle K2, 3, and 4 together, the sum is 180 degrees, meaning these two angles are supplementary, meaning K4, K3, K2 plus M2 and M3 together. If we can prove that the sum of these two is 180 degrees, that means, boom, co-interior angles are what? Are supplementary. Therefore, these lines are parallel. Two scenarios, you know?
Yes.
Yeah. So let's check out alternate angles. Let's just check out alternate angles quickly. So remember from the basis of answering the questions here, we found the size of angle N, we found the size of angle K2. Now we want to prove that MN and KS are parallel. Now we need to pretend as if we did not find all the things that we found, just what we have here. Right?
Okay.
So where would I move from there?
I think since we know that K3 plus K4 is 90 degrees, the radii perpendicular to the tangent.
Sure.
So we already proved that N is 80 degrees. So I think we should just find that angle K4 must be 80. So
Amen.
now we must get maybe angle 3 or angle 4. Angle K3 or K4, because we know both of them make 90 degrees. So we must just find one angle.
Oh, since
So let's just be specific. Like I mean let's go ahead and do this. So step by step, we already found that angle N is 80 degrees. So let's be specific. What is the first statement that you guys would write in proving that in your way to proving that MN is parallel to KS?
Angle N is equal to 80 degrees proved.
Okay, sure. Angle N is equal to 80 degrees proved. Thank you. Then
I will just say K3 plus K4 is equal to 90 degrees.
K3 plus K4 is equal to 90 degrees. Reason?
Radii perpendicular to the tangent.
Okay, thank you. K3 plus K4 is equal to 90 degrees radius. Yeah. Tan perpendicular to rad, yes.
So let me see. I must find K3 or K4.
Yeah.
or we can use K2.
You can use K2.
You're going for A.
Since they asked about K2 in the previous question.
Yeah.
Okay. What about K2? What would we do with K2?
Oh.
K2 is equal to M2.
Yeah.
Which we found using that. Oh, yeah.
Yeah, we can use
K2.
the interior one.
So they are both equal to 10 degrees.
Sure. Okay.
And since K4 will be equal to M3 plus M2.
K4 is equal to M3
plus M2
plus M2.
10 chord theorem.
No, I have a shorter way.
No, okay, just hang on a sec. That's fine. We'll come back to that other way. So you say K4 is equal to M3 plus M2.
Yeah, the 10 chord theorem.
Okay.
Now K4 will be 80.
Yes.
And now since K4 is equal to N, it both equals to 80 degrees. This means that MN is parallel to KS, alternating angles.
Alternated angles equal. Yes. That's where that reason comes into play, because it's funny that sometimes people use that very reason when they want to actually say they see that two angles are actually They'll say angle n. Maybe we've already given parallel lines, and they want to say angle n is equal to k4, which is equal to 80 degrees, and then they'll say reason alternate angles equal. No, guys. So when we're proving lines are parallel, it's alternate angles equal. So we say mn is parallel to ks, alternate alt angles equal. So that's very, very, very important. Very, very, very important, that point. So yeah, so very well done with the alternate angles equal. Alternatively, how would we use the idea of co-interior angles supplementary?
I guess since we found K2 is equals to M2, which they are 10 degrees. So we have M3 70 degrees, we have M2 10 degrees, then we have K2 10 degrees, then we have K3 plus K4 as 90 degrees. We can add them to check if they are equals to 180.
And that's basically it. So you have that 90 there plus the 10, which is 100. And then you have that 70 plus the 10, which is 80. You add those two together, you can see that those two angles, angle NMK and angle SKM, they are equal to, together the sum is giving you 180 degrees. And you can conclude that MN is parallel to KS, co-int angles sup. Sup. Okay, yeah. Alright, guys, this was me just playing teasing, with the geometry. The geometry is nice, guys. It's very nice. Viewers, people that are online, you can see most. These guys, they are just playing nice games with geometry. Geometry is a beautiful ball section of grade 11 work. And honestly speaking, people, the geometry in grade 11 is probably the easiest geometry you will ever do in your whole high school career. And I mean that no joke or no jest, it's facts, but you need to give yourself time. You need to know your theorems very well. You need to know everything that you've ever done in geometry from grade 9 and grade 8, your basics, your lines, your parallel lines, your triangles, congruency, my goodness, similarity, midpoint theorem, hey, properties of quadrilaterals, those oftentimes, get left behind. We forget them, those properties of quadrilaterals. We need to know those. And then now here we are doing circle geometry in grade 11. So basically you need to know the theorems, all of them, and you need to know the diagrams, you need to know the statements, and you need to know the acceptable reasons. And then you need to just take those. Honestly speaking, I would say at the beginning, guys, if you really are struggling with the geometry, I would actually say that you draw all of those circles, you have them on a piece of paper. Then when you are doing riders, you just have those circles there available so that you can see each and every one of them with their accompanying acceptable reason. And then you just do them, guys. Like, honestly speaking, you just do them. You give yourself a chance to sit there and do the geometry. Then it basically must flow, and you'll see. Really, guys, it's fun. So I'm glad that these guys, these three musketeers, these three geniuses of light, or of maths light, Moles, Marco, and Oradile, I can only hope for more mathematical blessings for you this year with grade 11. And maybe we'll meet again when you tell me and report back and say, we got the 100% this term. We chowed it. Maths paper 1 was a breeze, June exam. It was like, I don't know what I was writing. And then maths paper 2, June exam, I killed it. And it was just a joy. So yeah, guys, I can only hope for the best. You guys must just go and do what you know what to do best, and just chow the maths. Otherwise, thank you guys for joining me. It was great. You guys are phenomenal. Like, truly, man, thank you so much. It was a joy. I feel like I'm a better person for having mingled and interacted with you guys over the content.
So can I ask?
Thank you, sir.
Sure.
Do you only do these ones of grade 11 geometry?
No. I don't do only these ones of grade 11, my later. It just depends on the day, you know. Like right now, today, I just thought, let me just come on here and let's do some, you know, grade 11 Euclidean geometry. Otherwise, it's all of them, my later. If there's grade 12 geometry, we do it. If there's grade 10 geometry, we do it. We do every sort of geometry, my later.
So when are you gonna do geometry grade 12? The ones with proportions.
DeMarco, you see, the thing is, I can never tell when I'm going to do it, the next live lesson. Thing is, to be
Okay,
honest, I am so crazy busy. It's not even funny. So, but let me see, like, when next I can actually make time, because I can't truthfully say, like, for instance, no, I'll do it tomorrow, or I'll do it the day after tomorrow. You guys are just going to have to catch me, you know, yeah, when you catch me. But what I do as well is that after I've done these live lessons, I actually upload them onto my YouTube channel. So people will hear you, DeMarco, doing the things. And hopefully I've gotten the permission from you guys to actually do that so that people can watch the interaction and all of that stuff from you all. Yeah.
So how can we find you on YouTube? Is it this maths?
It's still the same. Maths is a game. It's just capital letters, buddy. Like, maths is a game. Maths is a game. All maths is a game. You can go on my bio. There's a link on my bio as well. So I utilize that brand. It's all a game, man. We just play maths, man. Play maths.
Yeah, it's a game, yeah.
okay, so
Yeah, but in future, because I haven't as of yet done a grade 12 session with proportionality theorem, similarity, and the area type questions, but we'll do it, man. I'll set it up. Just make sure that you follow and all of that stuff, so that when I do go live, you can get a notification. But it will usually be at after like an evening sort of like session time, 9 and beyond. So yeah.
okay, sir.
Yeah.
Thanks.
Otherwise, thanks again, gents. You guys have been amazing. Thank you again.
Thank you, sir.
Yeah, sure, man.
Thank you, sir.
Sure, guys. Yeah. It was epico. No, that was amazing. Like, yeah, I enjoyed my time with those guys. Phenomenal guys. My goodness. Yo. Math slayers at their best. You know what I mean? Math slayers, guys. Math slayers. Making the subject be weak. That's what I'm talking about. Math slayers. Giant math slayers. And my hope is that you guys can continue to just do the most. Yeah, guys, I'm gonna sign out. It's a long day up ahead. Classes galore tomorrow, so let's see each other again, maybe at another time. We'll have another jam-packed session. But like, yeah, we are just going to do this geometry until people get sick of it, you know, on these live lessons. Then grade 12s, I'll definitely have a session with you. You guys have no idea what I have cooked up for the grade 12s, especially considering that some of you kind of tend to feel that the geometry in grade 12 is difficult. Guys, it's weak as well. Grade 12 geometry is weak. It's weak with its proportionality theorem. It's weak with its similarity. It's weak with its midpoint integration from the grade 10 syllabus. It's just weak. Area questions, weak. So we'll look at that and we will see how weak. And I'll suggest some strategies for you guys for the grade 12 syllabus as well come that time. So just, yeah, you can wait for it. It will come up in the next few. Just be patient with me. Hang on. But we'll see each other. So thank you so much. Thank you for joining in, and thank you for being so patient. You guys have been a great sport. And really and truly thank you for the likes. I see the likes went up to 21.9k. Like, you guys are phenomenal. Yeah, and thank you again. Definitely associate and mingle with the guys that were here helping me out. These are guys that you can basically get on the side, like maybe have a WhatsApp chat with these specific individuals that were on here, that were helping me out, because those are the kind of friends you want to be associating with as a grade 11 learner. Sort of the sort of mindset that they have is a sort of mindset that you can see is progressive academically. I love that. it was funny because even one of the learners, just I forget who it was specifically that I was saying, he was just thumping through his WhatsApp. I mean, sorry, his TikTok, watching videos, and then when he came across the maths, he was like, he needs to tune into this. And I mean, from watching entertaining videos to just coming through a live session, and you're like, I love maths, I just had to come on here. That's amazing. Yes. So you people like Oratile, DiMarco, I'm sure they are definitely would not have no problem with assisting some of you, you see. Because I know some of you, all you need is sort of like the right association so that you can be able to see that it's possible. It's not as difficult, Yeah. I'm all for that kind of good association. So please, guys, associate with the right people and have fun with it. Yes, definitely, Debs. Maths is fun, Bob. It's super fun. Okay, guys, cheerio, tootles. I am out of here, Yeah, Moles. Okay, guys, please check out. You see what Moles is saying there, and that's the thing. Please, guys, share with each other. There's many people that are doing a lot of phenomenal things online. So Moles, for instance, just recommended there. Check out the account Certified Jules. It makes notes on geometry. Okay, please, guys, do that. Do that. Okay, do that. Be productive. I'm not having fun in engineering with calculus 3. You're killing me. You're killing me. No. Hey, it happens, that one, eh? It happens for sure. No, my little, you must also fight there with that calculus 3 in engineering. There's no other way. Mr. Be Productive, you are the one that needs to come back here on this platform and be a source of motivation. That, yes, hey, there was a time when it was not fun and it was hard and it was tough, but I came through it all. I came through it all and I was able to survive. And because of that, I am the person that I am, and because of, Debs are there. Look at guys, look at that. Please, you see, there's help everywhere. Okay, so Mr. Be Productive. You have Debs are there that can help you out there. You can assist with that calculus for engineering maths. Okay, please check out Debs are there. Mr. Debs are there. The one and only Debs are. He can help you out with that calculus for engineering. Okay, so there's help everywhere. And thank you so much for availing yourself, Mr. Debs. It helps a lot there. It helps a lot. DeMarco said, please do counting principles with your learners also. No, we'll do that. Don't worry. The time will come for that. I'm actually intending to do that counting principle in that season and period between the transition of term 3 to term 4. Term 2 to term 3. Because remember, counting principle is done in term 3. As a syllabus, the topic is covered in term 3. But what I will do is that in that interim holiday break between the transition of term 2 to term 3, I will do in the holiday break counting principle, so that by the time people hit the ground running at schools with the counting principles, they're like, Asuka, this thing is water. It's nothing, I can't feel it. I'm too warm for it. I'm too warm for it. Counting principles, my favor. Utini baba. Oh, Debsa. Debsa, man, seems to be a hot one there, guys. You must check out Debsa there. Check out Debsa. Follow Debsa. Follow Debsa hard. Please follow Debsa there. How do you build passion for maths? Guys, what are your thoughts? Mr. Be Productive there, I think, is probably feeling it hardcore and is feeling a bit passionless in the university terrain, doing calculus 3. I can imagine, Baba. Habo, Moles, how can trigonometry be your friend but algebra is your enemy? Moles, do you realize that much of trigonometry has its foundations, has algebra as its foundations? For instance, if you're doing general solution, solving trigonometric equations, simplifying trigonometric, expressions, are you kidding me? Man. Yeah. Moles, you need to change that around. You can't have trigonometry be your friend, but algebra be your enemy. Because trigonometry can only be your friend if algebra is a good friend of yours. Because I'm thinking to myself, how in the world are you going to survive with identities? How are you going to survive with a simplification of trigonometric expressions? There's no way. So what I suggest then, Mr. Moles, is that you change around that narrative. You make sure that that narrative changes ASAP, so that your algebra becomes your friend. You need to love algebra. Algebra is to be loved. Sure, and it's so foundational to so many things that you do in your high school mathematics. So yeah, and it's marks. It's easy marks. It's giveaway marks, the algebra, bro. So please, bro, can't be like making algebra not. No. You must love each other. You need to spend more time. Jean doesn't love me back. No. Moles, you need to throw yourself that much more. You need to throw yourself that much more. This is like me sitting in marriage counsel with a couple that is contemplating divorce, and that couple is contemplating divorce because of many years of having had like the same raw experiences, and they're like thinking that we need to end this thing. No, you need to reignite the flame. You need to reignite the flame, please. Reignite the flame, Moles, please. ASAP. You have no time. You need to reignite that flame, and you need to make sure that you cultivate a authentic relationship, one that is devoid of any pretense. It must be a authentic, real relationship from here on, and you need to romance algebra. You need to spend time with algebra. You need to give it, its due time. I'm molest. No, we need to change that for you. You need to change that. Yeah. Who said it? Fear, face everything and run. No, that fear. Face everything and rise. That's the acronym. That's the proper acronym for fear. Face everything and rise. You need to face it. You need to face it. You need to face it head on, the algebra, so that you can just rise from here on. And I think it's a matter of like you need to take, because for instance, if you're thinking about like in algebra, your typical grade 11 and grade 12 paper at the beginning of algebra, you look at like the first question, solve for x. Are you trying to tell me that factorization is a pain for you? Yeah. Please do. Yes, Moles. Okay, I like that statement. But like, yeah, so it's solve for x. So your factorization needs to be on point. Solve for x. Quadratic formula, you need to be able to utilize the formula, the quadratic formula. Third equations, inequalities. Nah, dude. What else is there? Simultaneous equations, nature of roots, exponents, exponential equations, simplifications of exponents, surds, rationalizing of denominators, exponential equations, of course, as I had said, both rational exponents. You've got a rational equation exponents, and also your the others. The problem is questions that start with if. So that is your 1.3, usually your 1.3 questions for grade 11 or grade 12. 1.3. I mean, that's so basically you are struggling with only one thing in your algebra. It's the if questions. My leader, even those ones, there's always a way out. Like I said, you need to sort of like be able to think a little bit outside the box, and then be able to implement some algebra in being able to dismantle problems. So I think even with that, it's always a way out, man. It's always a way out. Good people, I've been rambling now. It's literally 12 midnight. Like, I feel a bit eerie because, like, you know what they say, maybe you don't know what they say, but it's 12 midnight. So let me leave love and leave you. Thank you so much. It was really great having you guys around. It was really good. I enjoyed the session for the geometry. Hopefully I can just get a chance and upload it. But take care. Lots and lots of maths love there. Have a good one. Cheers. Bye.